Hello class, this video is going to demonstrate rotational motion. When you look at rotational motion, there is a tangential velocity associated with a point on a rotating object. So when you rotate this disc, that point on the edge is going to have a particular tangential velocity. The tangential velocity is the angular velocity of the disc times the radius of that point from the axis of rotation at the center. So if you look at these two spots that are rotating on this disc, there is one about halfway from the center and one at the edge. You can see which one has a greater tangential velocity. You can see when you rotate one revolution, so now we'll stop this. If you go one revolution, the distance that the point travels has to be the circumference of the circular path that it makes. So therefore, when you do one revolution, a point at the edge of the disc has to cover a greater circumference than the point that is halfway from the center at the axis of rotation. So with that, the angular velocity of both of these points is of course the same. The angular velocity is a constant no matter where you are on a rotating object. Therefore, the tangential velocity depends on the radius. So the further away from the axis of rotation you are going to have a greater tangential velocity. So you can see here the point at the edge has a tangential velocity that is roughly doubled that point that is roughly halfway out. Furthermore, with that, when you look at angular velocity is angular displacement divided by the time. So that's the angular velocity. The angular displacements will be the same for all points, so you have a constant angular velocity. Now, angular acceleration is the time rate of change of angular velocity. So when you speed this up, you have a particular angular acceleration in radians per second squared. And when you slow this down, you have like an angular deceleration for slowing it down.